So welcome everybody that's joining us on YouTube. So today it is March 27th. This is our third day of remote learning. And we are gonna finish up section 2.3 today and move into section 2.4. So since last time I asked people to think about this activity that's up 2.3.4, and I'm gonna kick it over to the people who are here and see if we have questions. So are there any particular questions that we had, things that you wanted me to go through or go over? These are all good? Everybody's good with all of these? So Emily's good with all of them. Thumbs up. Yeah, if you want me to go through one of these, you can drop it in the chat or you can speak up now. Part E? Yeah, part E. Okay, so we're given some information about the value of the derivatives, and then we want to figure out, hey, if we look at the products or the quotients, what can we do? So, what's the best way to do this here? So what I'm going to do is I will write down this information, then we'll go over to the blackboard, and I can work through this one. Okay, so we're given 4 values. We're given our input is 3, right? So this is going to be our x value is 3, and then what we're given is the values of the functions and the values of their derivatives at these respective points, and we're asked to figure out, hey, if we multiply the functions together or divide them, how do we compute the derivative? Okay, so so I'm gonna reshare here. So what do you all see? Do you see that book just frozen on the screen, or do you see something else? You see the book just frozen? Oh, okay. So I have to reset the iPad here. Okay. All right, so you can all see this? See the blackboard? All right, so the information that we are given is we have f of 3 is equal to -2. We have g of 3 is equal to 4. And then we have f prime, the derivative at 3 of f, is equal to 7. And then g prime at 3, this one is equal to -1. Okay, so this is all the information that we have. And what we want to do is we want to take this information and we want to figure out first, if I have a product, right? So if I have this function p of x, which is equal to f of x times g of x, the question was, what is the value of the derivative of p at 3? What is p prime of 3? Okay, so types of questions like this, I think there's one like this on the web work as well. And so what we're doing is instead of having the function, this is a way to assess your understanding of the product and quotient rules without actually giving you the function. So what we want to do is understand, hey, if I have a product of 2 functions here, f of x times g of x, then what is p prime of x going to look like? So p prime of x, we know, is this is the product rule. So we have our f of x times g prime of x plus f prime of x times g of x. And so anytime I take the derivative of p, no matter what the products are, I'm going to use this product rule. And so when I look at p prime of 3, what I'm going to get is this is f of 3 times g prime of 3 plus f prime of 3 times g of 3. Okay, so when I look at this, what I'm given is I'm given 4 values. So I'm given that f of 3, right? I know that value. I know g of 3 is here in blue. Then I know f prime of 3, which is this. Oops, I messed up here. So this shouldn't be blue. So let's go back. So g of 3 is over here in blue, and then g prime of 3 will underline in yellow. Okay, so when I look at it this way, what I have is we have right, f prime, g prime, f and g. We have all these values, so I go down below, I plug them in. And so f of 3, this would be -2 times g prime of 3 is -1 plus f prime of 3, this is our green, that's 7. And then g of 3, this is 4. And so putting all this together, we get 2 plus 28, which ends up being 30. Okay, so I'll pause here for a minute just to let everybody sort of catch up. How does this feel? How does it look? Thumbs up, thumbs up. Move around. All right, so yeah, just where we have the values. Now, we can do something very similar. We're going to try our whiteboard skills here. Yeah, we got a lot of moving parts. So how do we do this? All right, so I'm going to, if people want to take a screenshot of this, I know it's going to be on video as well. I'm going to go ahead and erase this bottom part. I'm going to leave the top left up here so we have the values, and we'll do the quotient. We'll do the quotient part, okay? So I'll give you, say, 10 seconds or something if you want to grab a screenshot of this. Right, so I'm going to go ahead and just start deleting stuff. All right, so now the second piece, we were asked about a quotient, okay? So q of x is going to be the quotient. So you're going to have f of x over g of x. And when we do this one, we're going to think about quotient rule. So again, we have our values, right? So we can color code them. Here's red, here's blue, here's green, here's yellow. And now when we think about the quotient rule, if I write it out in general, the quotient rule, all the pieces are going to be one of these 4 things. Right, so we're going to have low d high minus high d low all over low squared. And so then when we get down to it, we'll be able to plug in all these different values. Okay, so let's go through that quickly. So q prime is the quotient rule, right? So you get low d high minus high d low. Then all of this is going to be divided by low squared. Right, so g of x squared, our denominator. So here's my quotient rule, and I'm just going to go through and I'm going to think about, hey, where are my f of values? So we're going to plug in 3's for all these x's. So this is going to end up being f of 3. So we'll see here, where are our g's, right? So here, this is going to be g of 3, and this is going to be g of 3 as well. And then f prime we're going to have here, and then g prime we're going to have over here. Okay, so we can go through, plug in all of our values. So g of 3, this ends up being 4 times 7 minus -2 times -1, all divided by 4 squared. And so what we end up with is we get, this is 28 minus 2 all over 16. So you get 26 over 16. And then you could reduce this if you wanted to. You could make it 13 over 8. So something like this. Right, so we don't have the functions, but we do have the values, right? So if we know certain values, we can still say a lot about how we combine them. All right, so pausing here, Well, questions, comments, concerns? This feels good. So Luke, you threw this one out here. How do you feel about it?
Definitely a lot better.
A lot better?
Something way different.
All right, all right. Okay. Still good? All right, all right. So let's jump back over to the book. I do want to go through one other example here. So you can see that after this, right? So after this activity, this is the end of our section. You can see the summary here. But there's one type of question that tends to pop up that in the book, they kind of do a lot of types of questions that look like this one right here. So I want to take a moment and see if we can think about this. Okay, so so has anybody looked at this one yet? Oh, lots of no's. So why don't we take a minute on our own, and then, you know, I won't put us in the breakout rooms yet. So we'll do that later, but let's think about this one together, right? So on our own, and then feel free to throw questions in the chat, or just, you know, you can speak to the whole group. There's not too many of us here, 3, 6, 9. We got 11 of us, so not too many. Let's take 4 or 5 minutes. We'll think through this one, and then we'll talk about it. All right. So if you're stuck, you know, shout it out, and we'll see what we can do. All right. So while you're doing that, I'm going to see if I can make it so I can write on this. Excellent. So we're in a spot where I can write. So this is our P of X is in blue. Okay. You get a nice rendition of Mickey Mouse Clubhouse for you all. So as you're thinking along at home, I'm sort of writing on the screen. Can you all see my markup here as I'm marking up on this PDF? Yeah. Okay. So some shorthand up here, right? If I take the derivative of our product, we have our product rule. And so as we go through, we're going to have to think about, hey, what's the function value at these points, and then what's the value of the derivative at each of these points. So does anybody have any ideas about this first one? Things that you know, things that you don't know that you're not sure about? You can put it in the chat too if you don't want to talk. All right, any ideas? What do we got? Somebody brave. Yeah, 2 in for the x values, right? So, but we're going to plug them in, but then we have to get the values, right? So we're going to need to know, right? We're going to need to know one thing. We need to know what is p of 2, and we're going to need to know, or p of negative 2, and then we're going to need to know p prime of negative 2. Those are two different things. Okay, so if we think about this, this value right here, p, right? So just to save space, I didn't put the x's in there, but you're going to need to know, hey, what is p of negative 2? And in order to read it off the graph, I'm going to actually have to look at this point right here. Okay, so what we say, this p of negative 2, this would actually be 1, right? And then if I try to change my color here, if I want to do q, right? So q, we're going to do the same thing. Q of negative 2 is going to be down here. And then this q value is going to end up being negative 1. Okay, so we have some values in here. But I haven't found any of the derivatives yet. So what I need to go through, I need to think about, hey, what is q prime and what is p prime? So any ideas? So Caleb, you threw your arms up, or was that a stretch, or were you signaling to me?
It was a stretch.
Stretch. Okay, but now that you're talking, you got any ideas for these derivatives here, p prime and q prime?
You just take the slope of each piece, and then that would be the
exactly right. Yeah. So at negative 2, right? I'm going to look at the slope of this line. So the blue line over here, the slope of that line is going to be negative 2, right? So this is negative 2. So negative 2 is going to go over here, right? So what I did is I found, for my green, I found the slope here. And then, so do I have more colors here? Because I have blue. Bad choices, but for the green and blue. But then I'm going to find the slope of this green line, and it looks like the slope of the green line is positive 3. Right, so I'm going to plug all these values in here, and then what we'll end up with, this is 3 plus 2, which is equal to 5. Right, so as we're going through, I'm just finding their function values, and then I'm finding our derivatives by looking at the slope of the different pieces. Okay, so does r prime ever not exist? When does r prime not exist? Okay, so this derivative, this thing's not going to exist when any 4 of these pieces, right? So we have 4 pieces, p prime, q, q. So whenever these values don't exist, we are going to have, this whole thing is not going to exist. And so when I look around, it seems like the values of the function always exist, and so that's fine. But sometimes our derivatives don't exist, right? So specifically when we have these corners, remember we talked about functions being differentiable. So the derivative doesn't exist when you have these corner points here. And so at these 4 different corner points, well, we're not going to have derivatives. And so that corresponds to when x is -1 and when x is +1. So this whole thing, right, this product function is not going to exist at -1 and at +1. Okay. So how do we feel about this? This is seems okay. Kind of both problems today were in the same kind of vein where we have you know, we don't know exactly what the functions are, but we can figure out the value of the function and we can figure out the value of the derivative. And you can do this through graphs or you can do it through tables, right? So those are two of the different types of problems that we saw today. And I think this will help you out on the web work as well. Okay, so we're about halfway through our time, so I wanna throw it out to you if there's any more questions about product rule, quotient rule, and I want to take the last 25 minutes to talk about the next section where we talk about the other 4 trigonometric functions that aren't just sine and cosine. So any more questions about product rule, quotient rule? Things are good? All right. Okay, so let's jump out of here. And so what we're going to do is so we are going to go back. I'm going to go ahead and jump into our next section, which is derivatives of other trigonometric functions. So to start out here, is everybody familiar? Does everybody remember how we define the 4 trigonometric functions? Right, so everything is based on sine and cosine, and so you may have remembered something like SOHCAHTOA or something like that, right? So we're based on these functions, but what everything is going to come down to today is going to be these 4 definitions right here. So tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and then cosecant is 1 over sine. Okay, so I think it's going to be really helpful for us to write these down so we have them in our back pocket. Right, so write these down, and then I'm going to take a moment to also record them and put them on our doc cam. So you can see me get this set up over here. Okay. So let's go ahead and okay. We can see this if I flip it around. Here we go.
It's still on the.
Yeah, so I'm setting up this cam. So if I spotlight this, you can see this here. Okay, so same thing before. I'm gonna put our definitions up here, sine, cosine, tangent, just so we have them available to us. Okay, so we have the tangent function is sine over cosine. Then we have the cotangent function is defined to be cosine theta over sine theta. And then we have our secant is defined to be 1 over cosine. Then we're going to have cosecant, which is 1 over sine. So if you want to, right, so I have this video spotlighted, and then we have them up there for a reference. Okay, so if I'm going to take the derivatives of these functions, so if I have tangent and I want to take its derivative, it's going to be sine over cosine. And I just want you to all note that what that is a quotient. Okay, so we're taking two functions, we're dividing them. So if I'm going to go through and think about this derivative, quotient rule is going to come into play. So now that we've derived quotient rule and we understand that, we can go through and figure out, hey, what are the derivatives of these other four functions? You can see that they're all defined as a quotient. And so in this preview activity, there's so there is a outline of what the proof is. So if you want to bring this up, so on a different screen or something, if you want to bring up this preview activity, so what I'll do is I will walk through this on our Blackboard, so we can all see sort of this process, and then I'll have us try to figure out some of these others on our own, and then we'll wrap it up with what the summary is, all of the different trig functions. Okay. So our goal is going to be to take the derivative of tangent, and we're going to do that using quotient rule. Okay. All right. So if we go along here, right, so our tangent function, we have tan theta is equal to sine theta over cosine theta. All right, so when I take this derivative, I'm going to go ahead and use quotient rule. And so that's going to tell me that if I take the derivative, what I need is I need to think about this as, right, low d high. So we're going to have something like this. So let's go ahead and make that a little bit bigger. So low d high minus high d low all over low squared. Okay. So I set up my framework and I'm going to start filling things in, right? So whenever I say low, that is the denominator, high is the numerator, and then d high is the derivative of the numerator, and d low is the derivative of the denominator. So we get low, which is just cosine theta. Derivative of our numerator, derivative of sine is cosine, minus high, right? So high, we don't have to do anything. So d low, the derivative of the denominator, derivative of cosine is negative sine. All of this divided by low cosine theta squared. Okay. So now we do some algebra. So notice that I have two negative signs here. So what I can do is I can put them together to make a plus. All right, so we'll go ahead and we get rid of this negative sign and this one over here, and then those become a plus in the middle. And looking at my numerator, what I have is I have something that looks like cosine squared. Okay, so this right here, this is cosine squared theta. And then if I look at this piece right here, okay, so this is sine squared theta. Okay, so what I have, if I put it all together, is cosine squared plus
When
sine.
you change that sign to a positive, wouldn't it affect the first sign in the first parentheses? Wouldn't that become a negative sign?
So not in this case. So since everything is being multiplied together, really what you get is, so if we sort of bring this out, we're going to have a negative, sine of theta times negative sine theta, right? So it was a minus sign. So what I have is I have two negatives here, right? So it's like two copies of -1. and I have 2 sine of thetas. So if we put them together, the 2 negatives make +1, and then the 2 sines become sine squared.
Makes sense.
Okay, so now what happens is we have an identity which says anytime we have sine squared plus cosine squared, that is always equal to 1. So are we, if we go back, let me go back to the grid view here. Are we familiar with that? Sine squared plus cosine squared is equal to 1. Does that ring a bell? Thumbs up, thumbs down. I got 1, 2 thumbs up. So sine squared plus cosine squared. So briefly, the idea behind that is the sine and cosine functions are defined as the x and y coordinates on your unit circle. Okay, so if we do a brief aside here, so anytime we have a unit circle, right? So if you think about it in the plane, the unit circle has equation x squared plus y squared equals 1. And cosine theta gives you the x coordinate along the unit circle. That's the definition of cosine. And sine theta, this gives you the y coordinate as you move along the unit circle. Okay, so whenever I think about this, if my x coordinates are, right, oops, highlighter, right, so if my x coordinates are cosine, and then my y coordinates are sine, when you put those things together, you end up with cosine squared, theta plus sine squared theta is equal to 1. Right, so brief aside on trigonometry. But this ends up being the fundamental trigonometric identity. So most of the identities that you see through pre-calculus pretty much come back down to this one. Sine squared plus cosine squared is always equal to 1. Right? So if we jump back here, with sine squared and cosine squared being 1, this numerator becomes 1 divided by cosine theta squared. Okay? And I want everybody to think about it this way, right? So this is 1 over cosine theta times 1 over cosine theta, right? So if I just break up my denominator, we get something that looks like this. And does everybody have our doc cam spotlighted here? So if I make this bigger. So our definition, so if you see where I'm pointing over here, right, secant theta is defined to be 1 over cosine of theta. And so what this ends up being is this right here, this is secant theta, and this is also secant theta. And so when we say the derivative of tangent ends up being secant squared. Right, so as we work through all of this, we say, hey, okay, I use quotient rule. I have one trigonometric identity that comes into play. And then it's absolutely correct. You could have stopped here and said, hey, the derivative of tangent is 1 over cosine theta squared. But if you look these up on the internet, or you look in the book, or most places, they're going to have it simplified. And so you're going to see it look like this. The derivative of tangent ends up being secant squared.
Why does the squared come before the theta?
So this is some notation that we use. So what this means is, so let's have another quick aside on notation here. So secant squared theta, what this means in notation is secant theta times secant theta. Okay, so there's some other ways that we could denote this, right? So we could write secant theta squared, right? So I could write something like this, but this is a little bit ambiguous. So the question when I look at this to me is, hey, does the square go with the with the theta, or does the square go with the whole thing? Okay, so in our standard math notation, there's two ways that this could be interpreted. It could be interpreted as, hey, I want to square the whole thing, or it could be interpreted as, hey, I want to square my input like this. And so it gives some confusion, right? So if I put the two outside like this, so instead, right, as a notational policy, we don't, right? So we don't put it like this. Instead, what we do is we move the two next to the secant, just so you can sort of rule out this possibility down here. So we say, okay, so by putting the two here, the notation means I'm going to have two copies of this function multiplied together. So does that make some more sense?
Yeah.
All right, Riley, I see your question here. Is it supposed to be a plus instead of multiplication?
At first,
So
it just
Riley, do you
looked
mean
like a dot.
right here?
No, it was earlier. It just looked like when you were doing the loady high at the very top, it looked like it was multiplication in between the 2 and the numerator.
Oh, this.
Yeah.
Oh,
but then you changed it and it was fine.
Okay. All right. Okay, so I'm gonna go back to my grid view here. Is this okay? Did I address all the questions people had? All right, so what I want to do is see if you all can try another one. All right, so if we go back to the book, a lot of the activities that I wanted people to work through, right? So cotangent is already done out for you. So let's go ahead and try out secant. Okay, so at home, right, just like we did before, you have a new secant function that's defined to be 1 over cosine. So go ahead and try to use quotient rule. So we'll take, say, 3-4 minutes here. Try out quotient rule on this one, on secant, and see if you can come up with what the derivative is. Now, again, if we want to know what the answer is, we'll scroll down on the page and it's down there at the bottom. But see if you can derive it, see if you can work through those steps, and then see if we can come back and match it up to what the answers are. So basically these two activities, they fall into the category for me where you could look up the answers, but this is you verifying, right? So we should be in the habit of verifying any sort of information that's given to us. And so this is how we can go out and verify that the information that we're getting is actually correct. Okay, so 3 minutes and try this one out and we'll come back together. So how did we get to this point so far? Set up our framework, took our derivatives, and some nice stuff happens. Okay, so briefly here, right? So this becomes 0, right? So we're going to get 0 minus negative sine theta, right? So that's going to be our numerator. And so our denominator is going to stay the same, right? So you get sine theta divided by cosine theta squared. So far, so good. Did everybody get to this spot? Right, so we took our derivative, yeah. And now we could stop here, right? So this is absolutely a fine way to write the derivative, but it does not match up with what you're gonna see on the internet, and it doesn't match up with what the derivative calculators are gonna do. So what we wanna do is see if we can turn it into the form that our book says. So let's go ahead and let's take a look at what our book says the answer is. Okay. So if we look here, they're telling us that the derivative of secant should be secant tangent. So if I look at this, derivative of secant is secant x tangent x. So somehow I need to change my formulas around to try and get this to be secant tangent. Okay, so our goal is to write this as secant theta times tan theta. Any ideas?
Just be sine over cosine.
So Luke, you had an idea. I wasn't able to hear you there.
Sine over cosine times 1 over cosine.
If you write it as sine over cosine and then times 1 over cosine.
So write it like this as 1 over, so I'm gonna do the 1 over cosine first. And then I can write it as sine theta over cosine theta. Pretty similar to what we did before, right? Break up our denominator. So if I look at it this way, yeah, so this, if I were to multiply these back together, this is cosine. And if I multiply these together, this is sine. So these are really the same. And then we know this piece, 1 over cosine, we saw earlier, this is really secant. And then sine over cosine is really tangent. Yeah, so you can rewrite it that way. Okay. And so the other ones are very similar. So if you do cosecant, it's going to be 1 over sine. It's going to be very, very similar to this, and you're going to make some of the same similar substitutions. Okay, so going back over to our book, right? We have the derivatives of these other trig functions are right here. So these are the 4 that you want. And it sort of adds to our list of derivative rules that we have. So at this point, we can take the derivative of all of the different 6 trig functions of sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so just scrolling up the other activities in this section, they were just like we did, right? So you could do the same thing. We did 2 out of the 4. The work for cotangent is all right here, right? So if you want to read along in the text, this is the all of the work for working out cotangent. And then cosecant is an activity, which is pretty similar. So if we look at this, so you can see that there are some questions here. Now I looked through homework 8, so there are 7 of the, I don't remember, I think there's 19 questions. So 7 of the 19 have some of these trig functions that we saw today. And most of the time the problems look something like this. So would it be helpful for me to say go through part D for you all before we stop, or are there other more pressing questions that you want to ask. So Luke, if you left it as sine over cosine on the exam, yeah, I think that would be correct. I think WebWork would accept that. So the way that WebWork does its numerical checks is it would still process, it should still process that as a correct answer. The journal, it's due at the end of the week, so by Sunday sometime, and just send me an email, right? So you could type it directly into the email, or you could attach a Word document. It doesn't matter to me which one. So as they come in, I'm just gonna check them off, and I'm just putting them all into a big folder in my email. So again, sort of, what do you notice around you? How has your life changed? You could write about math, right? Some of the struggles you're having with remote learning, that could be a thing that you talk about. If there are other things that are going on in your life, you could write about that too. So pretty much just sort of recording this historic moment in time, what your life is like, how it's changed, what you like about it. That would be a positive spin. What you don't like about it, what you're doing to cope, what you wish would happen, or anything like that. Other questions? As far as the derivatives go, it seems like most of us feel pretty comfortable with this stuff. And the WebWork is going okay. All right, so for next time, so let me drop this iPad here. Okay, so for next time, what we're gonna do is we are gonna get into, so next week we're gonna start thinking about chain rule. And so chain rule is how we process function composition. Okay, so when we have two functions that are composed together. So if you start working through section 2.5, and then pretty soon here, what I'm going to do is I'm going to post this stuff for next week. So I just want to take one last look at it, and I'll post the agenda on Plato. I'll reveal that week for us, and it'll have like the videos to watch. Pretty much we're just going down the playlist that's up is pretty nice. The people at Grand Valley State put it together, and I think the next 4 or 5 videos are chain rule. So chain rule typically is very one of the more challenging rules to get your mind around. So we'll probably spend a few days on that, and you can see online that there's several videos over it. Okay, so spend some time over the weekend if you want to reading that, and then on Monday we'll jump in with section 2.5 and talking about the chain rule. Okay. So any other questions? We're 1 minute over here, but any last questions before we go for the weekend? All right. Caleb, we can always do math. There's always more math to do. It's not lies, right? So math is everywhere. I was geeking out over a New York Times article this morning. It was really cool. They did some modeling around stuff. So there's lots of math modeling out there. If you're reading the news, you'll see lots of graphs, lots of math. So these are the tools. All this calculus, these are the tools that we use to model the world around us. So lots of good stuff. All right, so we're going to call it there. Have a great weekend, everybody. Stay safe, stay healthy, and then we'll see you back here on Monday morning. It's great to see you all. I look forward to it. I'm glad we have our sync sessions here. So have a great weekend. See you all.